So, in defense of bearing blocks, they actually do serve a real purpose and actually do make a difference. The thing about it is, it's going to take a really long time for you to actually get to a point where these things actually do something for you. So, let's talk about that. Now, it's important to remember that budget printers like the Ender 3 are not built to exacting specifications and ultra-tight tolerances. That's why they're budget printers, which can lead you to feel like everything that you do to fix a problem involving that issue feels more like a band-aid rather than a cure. We can actually bring that concept a step further. The fact that we're using a lead screw nut and a lead screw instead of a ball screw is just another example of cost cutting for a type of mechanism that provides linear motion via rotation, but being more cost effective at doing it. If you've ever looked at custom-made industrial 3D printers that are FDM based, you'll actually notice that just about every axis on those things use ball screws because they have almost zero backlash. They're extremely rigid, and they're most likely using very high-end ball screws, which end up costing around like $1,000 for something that is the same length as this, for just the ball screw and the shaft that it goes up and down on. But hey, when you work in R&D and your employer gives you an unlimited budget, what's to stop you? But that's not us. No, we are on a budget, and we're talking about an Ender 3. So let's get to talking about why this can help you with this. You see, the reality is the lead screw nut is made from a softer metal than the lead screw, and that's on purpose. It's cheaper to replace a lead screw nut than the lead screw itself. It's one of those things where if you have metal on metal contact, well, something's got to give, and if something has to give, you'd want it to be the less expensive and easier to replace component. So, as your lead screw twists and you have motion up and down, it's going to wear that lead screw nut over time. Now, the wearing on that lead screw nut is in fact in 3 different axes, not just one. So as this wears, it's going to move back and forth to the left and the right, front and back, and up and down. Now that's a problem because the more we wear it out, the more wiggle is going to happen as you move up and down. You see, this wobble and play right here is what happens when a lead screw nut has been used for many, many hours. And despite using lubrication, eventually something is gonna give. So that causes problems because when your stepper motor is rotating and this is just kind of moving your gantry up and down, eventually, you're going to get to a point where this lead screw nut is so worn that the lead screw starts to rotate and starts bending in directions other than straight up and down. So this lead screw can be pitched to the left, pitched to the right, front, back, even up and down a tiny bit, although up and down is not as big of a deal. And in fact, this is why a bearing block ain't such a bad idea. You see, when the lead screw nut starts to wear, gravity is going to push down the gantry onto the lead screw nut, onto the threads of this thing anyway, so you don't got to worry much about that. It's more the lateral motions that you need to worry about, the front and back, left and right. So, in order to prevent that, we stabilize the lead screw at the very top with a bearing block. And that prevents some wobbling from happening as you go up and down from lead screw nut wearing. Now, it's very important to note that you gotta be very good at setting up and aligning this lead screw, because the main problem that I see, or the main complaint that I see, is that people think this thing is going to destroy your lead screw and cause deflection, which will in turn create an issue where your machine thinks it's gone up or down a certain distance, and physically in the real world, outside of its programming, it doesn't reflect that. You see, let's say the lead screw's bearing block is holding this lead screw in one position, but the stepper motor is holding it in another position slightly off center. Well, what that's going to cause is the lead screw itself to bend. And yes, these do in fact bend. These lead screws are not made of a super rigid metal. This stuff will actually give and flex a little bit, causing deflection. So that deflection causes what, let's say, 100 millimeters up to be less than 100 millimeters up, because now your lead screw is bent, and if it's bent, well, you're not going to get the accurate motion that you need. And that's what people are afraid of with these bearing blocks. But here's the thing. Bearing blocks are only supposed to be used when everything is aligned perfectly. And the reality is, if you're using a budget 3D printer, alignment is a problem. You have issues getting the stepper motor to align exactly with the position of where the lead screw nut would be, and then having the bearing block on top also reflect that exact horizontal X and Y axis position. In an ideal world, your stepper motor would have its shaft perfectly aligned in the center of your lead screw. Your lead screw nuts would be perfectly aligned with wherever it's connecting on the gantry to reflect the position of that stepper motor shaft, and the top of the lead screw with its bearing block would also reflect that perfect alignment. They should not be out of parallel. They should not be causing any sort of deflection on the lead screw, and thus you should not have any sort of issues using a bearing block. But then people would say, hey, what's the point of the bearing block then if everything is perfectly aligned? You wouldn't need anything to actually hold it straight because everything is straight. Well, yes, it will be straight for a while until a few thousand hours later and your lead screw starts to wear. And then your lead screw starts to kind of float around in the lead screw nut. That's why, assuming everything is perfectly aligned, and by the way, shameless plug, if you're looking for something to align your Z-axis stepper motors on your Ender 3 Pro, I've actually designed something to help fix that issue that will help you align that motor front and back, left and right, so that you can get it perfectly aligned. And on top of that, if you're using any sort of bearing block outside of one that can be adjusted on the X-axis and the Y-axis like this, you're not using a good bearing block. Now let's be clear, everything has to be perfect for this system to work as intended. This bracket has to come out at a 90-degree angle, not 89, not 91, 90 degrees. This has to be flat and completely square with this bracket. A lot of times Creality doesn't ship them to you like that. So this is something that needs to be adjusted most of the time. Now, they often don't give you any way to align your Z-stepper motor in the direction that you need to get it lined up with this part of the bracket right here, where your lead screw nut is positioned to, should not be wobbling. Your lead screw nut should be completely firm and in place so that the lead screw is perfectly up and down, not tilting or bending in any particular direction. And once you have it perfectly straight up and down, you're aligning the shaft of this motor with a thing that I've designed right here, whether it needs to go to the left or to the right, front or back, to achieve that so that it is perfectly in harmony with the parallel alignments of this lead screw nut. Then you've got yourself a system that should move straight up and down and shouldn't cause any deflection or bending of the lead screw. Now, on top of that, you're going to do the exact same thing with this bearing block up here. This bearing block is going to move left and right, and up on the top you can move it forward and backwards, the exact same way that we adjusted the stepper motor down here. And that will allow you to get the lead screw up on the top stabilized in a manner that is not going to, once again, bend the lead screw. Anything that can cause the lead screw to bend is not good, because that's going to cause premature wear on the lead screw nut. It's going to cause inaccuracies in your Z height, because when you bend that lead screw, 100 millimeters up is no longer completely 100 millimeters. That's just the reality of the situation. But when you have all of that taken care of and aligned properly, and this is in place properly, as that nut starts to wear, where the lead screw could theoretically move forward and backwards, left and right, it won't. Because up here, it's stabilized, and it can't do that anymore. So the only real play that you'll have is up and down from wear on the threads on the top and the bottom. But because of the force of gravity pushing down on the gantry, which pushes down on the lead screw nut onto the threads, you shouldn't have that problem either. This bearing block is not about improving the quality of your prints. It's about maintaining the consistency of your prints. And in order to really use this properly, you need to have everything else perfect. If you can't get that, if you can't get a perfectly aligned shaft, lead screw, and lead screw nut, you shouldn't be using this, because you will end up bending the lead screw, which will cause more problems than anything. But if you can, take the time to align everything exactamundo, then this is actually a great idea. Because the wearing part would become less of an issue. You're still going to have to replace it after a certain point, but you shouldn't have to replace it as often.